depending on the age of one's fossil locality, current animals help enormously. And so that's because many of the kinds of animals present now had ancestors that were active, that were alive back for many tens of millions of years in the past. So that means we can go to a modern zoology museum, look at the skeletal collection, and determine there what are going to be the characteristic features of, say, the limb elements of an antelope compared to the limb elements of a horse. Now, that's not to say those don't evolve over time, but nonetheless, there are still distinctive differences that would allow one to recognize the antelope configuration compared to the horse configuration. Farther back in time, when we're dealing with mammals that are, for example, from 50 to 60 million years ago and older, they are still related to animals that are alive today, but at that point in time, mammals were fairly different from what they are now. There were many fewer large-bodied animals. The environments were different. They made their living in a different way, and so we start to get into an area where we're dealing with kinds of mammals, many of which did not survive to the present day. So then you simply have to become an expert on fossils of that time period and know how to tell one group from the other. Farther back still, we have less and less ability to use our modern plants and animals to compare in precise anatomy to those that were, to animals or plants that were present, say, 100 million years ago or older. Nonetheless, because they're fossil deposits that have huge numbers of plants and animals of those times, we can look at what is consistent for those times. And fortunately, almost every time period has some fossil deposit where you do get beautifully preserved whole skeletons, and then you know exactly what bones go from in a single individual. And that's extremely informative for telling what kind of bone you have when you're dealing with a scatter of bones from many different individuals. And so those are the ways that you do it. And I have to say, I want to give the impression, I don't want to give the impression that we pick up every bone and say, aha, it's this particular genus and species. Sometimes we say, okay, we can identify this to family. Sometimes we say we can identify it to taxonomic order. For example, we might say it's the even-toed ungulates, not the odd-toed ungulates. But sometimes we find a bone that is so unusual, either because it's so eroded or because it's actually of something so distinct, so different from anything alive today, that we say from time to time, we don't know what it is. We call it a mystery bone. Then sometimes those turn out to be really interesting clues to some new kind of organism. And in other cases, they just turn out to be eroded beyond recognition. So we get mystery bones that we'll never be able to identify, and then we sometimes get mystery bones that turn out to be something really new and exciting.